Many old solar lanterns are thrown away. Often within a year, when the battery is damaged for whatever reason, a bad charge circuit or whatever. You can name it. But these, say, solar cells, and I've used here a 4-element solar cell, can be used again. This is one of these typical solar cells, often thrown away, I think by the hundred thousands, perhaps even by the millions. And that is, in my opinion, a kind of pain. Anyway, here another typical mini solar cell. You can see the deterioration on the plastic due to the ultraviolet light of the sun, and they of course have a positive and a minus. Here the white lead is the positive, but even this old solar cell can be reused, and I made a circuit for that. I made it, by the way, especially in a very sturdy way, and it's a light sensitive relay. It's made with such a discarded solar cell. And this is of course a schematic. I've made both the schematic and the drawing about how to make it in reality. This is the schematic. It is a Schmitt Trigger, and that is a very important, because when you look on the World Wide Web you can often see a comparator circuit made with an op-amp, say a 741 or a TL80 or 81, and then in that case they use the two inputs of the op-amp. But I found in practice that for such a circuit, say where a light has to switch off definitely without any hesitation in between, you need a Schmitt Trigger. And when you make this circuit with an op-amp, surely possible, no problems with that. But there could be a moment where the relay starts to click, say a kind of flickering inside to the coil of the relay. It starts to click, clack, etc., etc., and the say the load that has to be switched on the, say, on this part of the circuit also gets, say, connection for a very short moment, click, clack, and that surely means that when you have here a critical load, be a motor or so, that surely doesn't work. The motor will take an enormous inrush current, a fraction of a second later it stops, and a fraction of a second later it goes on again, it works again. But anyway, that's why you need a Schmitt Trigger, and this is a Schmitt Trigger with a non-hesitating moment. It switches on or off, and this is the way you can make it in practice. And I am especially critical because when you want to, say, switch a heavy load here via that relay, it must be stable. Circuit must be stable anyway. So here's what I've made. You can see here the potentiometer. It's 47 kilo ohm. When you want to make it more stable, try it out in practice. So when the sun comes up and the relay switches, set it to a certain sensitivity. That sensitivity is set here with P1, potentiometer 1, 47 kilo ohms. It's here, the same potentiometer. and then use, when you have aligned it to your needs, take out the potentiometer, measure the different resistances here on that carbon layer and replace them by fixed value resistors. Of course, in that case the circuit is fixed to a certain, say, to where it acts on a certain amount of light. Well, let me show the schematic, how it works. At the moment it's dark and this is the sun. The sun comes up slowly and the relay switches. Sun goes down, switches off. Sun up, sun down. And you can surely hear and see that there's no hesitation in the circuit. Because that Schmitt trigger switches absolutely on or absolutely off. Demonstrate that again now when I use my hand here to cover the solar cell. I'm going to do that now. And of course, I am not talking about, say, the load that you have here. Could be a lamp, there's never a problem, say, when the circuit flickers or switches in an irregular way on and off. But when you have a motor, that could be a serious problem. Anyway, I think this is a sturdy circuit. The relay is made for 12 volt. The DC resistance is 140 ohms. You can measure that with the ohms meter. To give the circuit some stability, you can use here a 100 microfarad capacitor, even a 1000 microfarad capacitor. Say, to remove disturbing signals on the power supply lead. And well, furthermore, there's not so much more to tell. Thanks for watching. Schematic again. Well, perhaps interesting, when you make the relay a little bit sly, you can solder here an electrolytic capacitor in the order of 10 microfarad up to 100 microfarad or so. In that case, the relay will hang somewhat. Could hang somewhat. That could be necessary for certain cases anyway. And perhaps strange, the solar cell is connected in this way. The minus of the cell goes to the base of the transistor and the positive of the cell goes here to the minus, and that is here the ground lead. Thanks for watching. Well, let me show the sensitivity. Here you can set the sensitivity via that 47K potentiometer, all classical analog electronic, by the way. So here is a moment on that potentiometer here where of course the circuit, the Schmitt trigger, stops. But you can set it, and you can also set the sensitivity, of course, say by using a piece of paper or so that covers a little bit the solar cell, to make it, say, sensitive for a certain amount of light. That can be done experimentally. Again, thanks for watching. Pen over somewhat. Hope it is somewhat interesting. Old school analog electronics, but I think it works properly.